So this is Prequiz 3.1. And the first part here, number one, is you've got a 17-degree angle. Let me be more clear. Can we be quiet? There you go. Okay. So on this one, this one's easy. This is the trig angle. There's nothing triggy about that, right? Okay. So I can just simply, this thing is simply going to be 32 cos 17 in the x direction, 32 sine 17 in the y direction, right? So that ends up being 30.602 in the x. And then it's 32 sine 17, 9.3. And these are meters. Ta-da. Right? And the reason that I'm writing so many digits down is not necessarily that I know all of those to be accurate. I'm writing them down because I'm going to use those later to do part 5. Right? And that's why it says write down like 4 digits or something like that. I'm writing down even more than 4, right? Number 2 is reliably, whenever you do the skill set, all the skill sets will be different, right? And number 1 is always it is the trig angle. Number 2, it's always not the trig angle. So if you use the 23 degrees, when you do it, you're doing it wrong, okay? So let's figure out what it is. That's the first step, right? Okay, so that's 23 degrees, and that's 15 meters. But remember, we want this angle here, right? That's the angle we want to use. We always want to use that angle. So that is, well, it's more than 90, more than 180. It's more than 270, isn't it? It's 23 more than 270, so that makes it 293, right? So the trig angle is 293, right? Okay, and now we're ready to go. This guy is 15 cos 293. That should be a positive x component, right? That guy should be to the right. And we should have a larger negative y component, right? Okay, so plus 15 sine 293. That's 5.8686. I'll just say 861 meters in the x direction. And then this guy should be bigger than 5.861. It should be negative. Let's see if that's true. Sine of, and indeed it is, right? So minus 13.808 meters in the y direction. Why did they pick two things, x and y, that look so much like each other, and if you're not careful, they end up looking exactly like each other? So did everybody get that so far? Yeah. Okay, I'm going to keep going. I'm just going to go on to number 5. Number 5 says to calculate the sum of the vectors, right? So what is it that we do when we add the vectors? Do we just add x to x and y to y? Yeah, so this is number 5, which would be the next logical one. I don't know why I didn't put them in that order, right? So 30.602 plus 5.861 gives me 36.463. Right, and then this is 9.356 plus negative 13.808, negative 4. Right, and that's x direction, yeah? Okay. And now we're going to draw a picture of this guy, right? We're going to go over 36.464. From there, without lifting our pen up, we're going to go down 4.452, right? And then what's the next step? To make it an angle magnitude vector, what do we do? Angle and the magnitude. Yeah, right, yeah. Okay, so this angle here, I'm just going to find that angle there just for fun. Okay, you can find any angle you want, but I'm going to find that one. That one's going to be inverse tan. So tan minus 1 of 4.452 divided by 36.463. So second tan divided by and that is 6.96 degrees. Like that. And then the hypotenuse here is going to be the square root of 36.463 squared plus 4.452 squared. So square root of 36.463 squared plus 4.452 squared. And 36.7 is what I get. Ta-da. And so that's why it says, does it say 36.7, 6.96 degrees below the x-axis or something like that, right? So all I really want you to do is I need you to draw a picture of it. If you don't draw a picture, when I say draw a picture, the vector itself is an arrow. It's not okay to do this. You can't go. That's not a vector. Vectors have arrows. I don't know. I suspect that you think that's the vector itself. I don't know whether you think it's this way or this way, right? So when you draw these on the skill set, when you do this, when you practice these, right, make sure that the vector is an arrow. I would make the components arrows too. I think that's helpful, you know. But there it is, right? Questions about 1, 2, or 5? Are we okay? So when we do this skill set thing, right, what I'll have you do is have you check 1 and 2. Because if you mess up 1 and 2, you're not going to get 5 right. And there's no use doing all this work, adding them together and doing all this stuff, right, if you've made a mistake on 1 and 2. So, yeah, there we go. And then 3 is converted into an angle magnitude vector. Well, we kind of already know how to do that, right? But let's make sure we draw this correctly. So for 3, you're going to go, I always draw the x first and the y second. You could do it the other way, but I always do it this way because I see the x first and I'm a spaz if I don't have some routine, right? So here's 13.2 meters per second, right? And then from there, this is the trick, right? From the tip of the one I just drew, I'm going to go up 5.7. Okay, notice that this one is shorter than that one and I drew it shorter. Try to draw them sort of to scale. Don't be all like, I'm going to measure it with a ruler or something, but make shorter ones shorter and longer ones longer. Therefore, if I find this angle and I calculate that angle to be 63 degrees, could that possibly be correct? No, that could not be a 63 degree angle because that angle is smaller than 45 degrees, correct? Right? So I would know that I made a mistake. I probably found this angle or something like that, right? Okay, so drawing the things like to scale like that, like the longer components longer than the shorter ones, is really, really very helpful. Okay, that angle again is going to be inverse tan of the opposite side, right, over the adjacent side. So 5.7 over. So inverse tan 5.7 squared. Whoops, not squared. I'm getting ahead of myself. Divided by 13.2. So that angle there is 23.4 degrees. 234. And then, okay, and then the magnitude here, the magnitude is the hypotenuse, right? And so that's going to be the square root of 13.2 squared plus 5.7 squared. So square root of that's 14.4. Ta-da. And then do we have any questions about number 4? I don't need to talk about number 4, do I? So when it says add them up, add them. When it says subtract them, subtract them. And you're subtracting x from x and y from y. Yeah? Generally that's like the one that nobody ever misses, but you know, there it is. In physics and in projectile motion, we're going to use the linear kinematics formulas. We're going to do this a lot, and we're going to do this a lot. And we're not really going to do very much adding a couple of vectors. But we do that sometimes, so that's why we show you how to do it. Are there other questions about the pre-quiz? Because I'd rather get on with projectile motion, which is the reason why we learn vectors. Are we good? So again,